Hey everyone, and welcome to the stream. I haven't streamed in a very long time, and I had a couple of problems. Hey everyone, I don't know if the stream has started yet. I guess it has, because I had a couple of problems setting up the stream, so I'm uh, I'm a bit unsure if the stream is actually up right now, but I guess it is. So before we start, I'm just gonna have a quick check to see if the stream is really up. If it is, then we can get started and we can kind of immediately start with the goal of this stream. And I know the topic sounds a bit technical, but it's a really cool thing that I want to build in this stream and probably the future streams. I mean, it is kind of a relatively late night stream that I'm doing, so I mean, yeah, I, it was kind of spur in the moment. I mean, it is kind of a relatively late night stream that I'm. Alright, so the stream is up. That's pretty cool. Alright, so first let's just take a look at the agenda. So the agenda of this stream is very simple. We are going to be making a projectile motion system using Python. We are also going to first break out and work out some of the mathematics behind building a system like this. So we're going to work out through all the projectile motion mathematics first, and then we're going to use that math and potentially turn it into code. So that's kind of the goal of this entire stream. And this is to show you that how there's a intersection between mathematics and programming in sort of a fun way. So I've been wanting to build a system like this for a while now, but I've been too busy with a lot of academic commitments, and you know high school students, you have to study a lot. So I wasn't really able to make any videos. If you have been following this channel, my frequency of uploading has gone down drastically. I think my last video was like 2 to 3 months ago. I don't really remember when, but yeah, that's kind of when my last video was. I might start uploading a bit more now. I can't really promise a lot, but for now, enjoy the stream. So, alright, so we know our goal, and obviously, first thing we'll do is we'll break out and we'll work out all of the mathematics for this thing. Uh, I would highly recommend, if anyone is, I mean, no one's watching the stream right now, but I would recommend that if you are watching the stream after it's been uploaded, because I'll probably upload it to YouTube afterwards. uh, I would highly recommend someone to actually work out the math first, without me actually showing you. Believe me, it's really just high school math. So if you have done that high school math and physics, I think you should be perfectly able to work out all of this by yourself. I actually haven't done this myself, like beforehand. I'm doing it with you, so I think it's gonna be really fun to kind of get an idea of how this stuff will work. That's always a fun thing to do. Firstly, what I need to do is just mirror my iPad screen to my MacBook real quick. Okay, there we go. So now I should be able to kind of do whatever I do on my iPad should be visible to you guys, which is pretty cool. All right. So, what is our objective? Our objective is to kind of model a golf ball. When you're playing that kind of a 2D golf game, kind of like Angry Birds. I don't know if you guys have played a golf game like that. Because I mean, in my childhood, I do recall playing golf games like those ones. So, I mean, I kind of wanted to build something similar to that. Alright, so how do you actually model a projectile motion? That kind of so a projectile motion, somewhat. I mean, if you've studied in high school, it kind of sort of looks a little bit like a parabola. It looks something like this. I mean, usually you mark this as the height, or like let's say sy, which is the vertical displacement, and then you mark this as sx, which is the horizontal displacement of the projectile or the particle or whatever it is that you want to call it. Alright, so we have all that in fun, good, awesome. Alright, so how exactly do we model this? So, from what I've learned in my high school classes, I know for a fact that vectors can be resolved. If you don't know what I'm talking about, I'll show you. So basically, if I have some kind of a velocity vector, let's say u, well, I can kind of draw two vectors that are perpendicular to each other and kind of are horizontal and vertical to u, kind of like this. Now, obviously, u forms an angle theta to this and a 90 minus theta to the vertical vector. Now, if you apply some very basic trigonometry, then you will kind of understand the fact that if you are trying to represent this horizontal vector, that is really just u cos theta. And the vertical vector that I'm trying to represent is really just u sine theta. I'll leave this derivation up to an exercise for you guys. It's a very, very simple one, so you guys can check it out, try to do it by yourself. So it's u cos theta and u sine theta. So in this case, I can say that the x component of the velocity is u cos theta and the y component of velocity is u sine theta. So now what we do have is we have two components of the velocity of a projectile that is being fired at an angle theta. You can kind of see why this is a very important thing to have, because even when I'm playing golf, this is kind of what a golf system would look like. Alright, so we have a ux and a uy. Now we have to take into account resistive forces. Now in our case, for just the sake of simplicity, I'm not really going to be adding any kind of air resistance on a golf ball. Since once, I'm doing it in 2D and stuff, I don't want to deal with air resistance. It screws everything up, something that I don't really want to do. So alright, so we have our ux, we have our uy. That's nice and all. So what should I do now? Okay, now if I take into account resistive forces, which is my first order of concern, because I want to determine for a given angle theta, how can I calculate the maximum height and the maximum sx that my ball can go? Because that's kind of what I want to model, and I want to form an equation for it so I can actually put it into code and actually get some kind of an output. Alright, so if I look at this, the first thing that I can see is that ux should not have any kind of a resistive force. So in this case, I can just say that ux is equals to sx divided by time t. And in that case, if I want to figure out sx, then that's really just ux times t. Now ux can just be written together as u cos theta, right? And then I can multiply it by t. U cos theta is something that we know is a constant, since u is a constant and theta is a constant, so u cos theta has to be a constant. But how do I figure out t? So for t, I think we can make use of the y component of the equation. So I know that uy is u sine theta. Now I know for a fact that if I'm trying to figure out the maximum height, then at the maximum height, the velocity of the y component should be equal to 0. Now if we are assuming that there is no net force apart from gravity or the weight of the ball acting, then I can assume that there's a constant deceleration that the ball is facing. In that case, we can make use of the Stowart equation since the condition is satisfied for constant acceleration. So in this case, we know that Vy is 0 and Uy is u sine theta. We want to figure out what the... Now, we don't just want to figure out the maximum height. We want to figure out at what time does it reach that, because I want to figure out what is the maximum displacement. We can also figure out the maximum height. It's actually a very simple deal, but first, my first order of business is to figure out time. So how do I do that? Alright, so the first equation that pops into my mind is Vy equals Uy plus At. So I can rewrite that a bit simpler, which is just that I can kind of put in all the terms that I know. So I know that this is u sine theta. I'll write that down a bit better. So u sine theta minus gt, so that means that gt is u sine theta and t is really just u sine theta by g. So now we can simply plug that t in here, so I can just get that sx is u cos theta u sine theta by g. So that just tells me that sx is u square cos theta sine theta by g. So that gives me the value for sx. Now this is basically for a given angle theta, how far will my ball travel? So this is what the equation kind of sort of looks like. Now if I wanna figure out the maximum height, I mean I kind of don't really care about maximum height, but I wanna give some kind of a statistic or a prediction before the ball is being fired. I kind of wanna create like a aim assist in a golf game, something like that. So in that case, well, finding out a maximum height is a very simple deal as well. For this, we can just use of another one of the SWOT equations is I can just say Vy square equals Uy square minus 2gs. Sy, I think I should write it like that. So in this case, I want to figure out what Sy is. In this case, again, this is going to be 0. This is just going to be a u square sine square theta minus 2gsy. I can take the 2gsy on one side, and that's just u square sine square theta. That just tells me that Sy is equals to u square sine square theta divided by 2g. So that tells me the value for Sy. Now it is up to you, but you can figure out equations for maximizing Sx and Sy. It's actually a very simple thing to do. All you really need to do is you need to differentiate the two equations. So for example, if I just find out dsy by d, now for here, over here, I want to optimize for theta and not for u, because it makes sense that if I just increase velocity, it should technically just increase Sy. So we want to find out dsy by d theta. In this case, that just leaves you with just a u square, because u square remains a constant, and the sine square becomes a, so it becomes a, so here you just apply chain rule, so you get 2u square cos so 2u square cos theta sine square theta sorry sine theta, I guess you get that. I guess I'm right. Wait, oh okay, I made a tiny error. Alright, so we take the 2 down. Okay, wait, let's say sine square theta, we want to figure out the derivative of that. So that gives me a 2 sine theta cos theta. So I should get that, right? So 2 sine theta cos theta, and I divide it by a 2g. So this and this kind of goes away, it cancels off. So I pretty much just get that dsy by d theta is a u square cos theta sine theta by g. Now obviously if I want to maximize that, I want to make the derivative 0 in order to find the stationary points. So I say that 0 is u square cos theta sine theta, since the g kind of just goes up there. U also can go into the LHS and pretty much become 0, so we can just get that cos theta sine theta equals 0. Pretty much just get that. So that pretty much says that cos theta equals 0 or sine theta equals 0, and here that just leaves you with theta, and so here you can get an equation for theta, which is that theta should be equal to, now if you look at cos theta 0, well, I know that cos theta is 0 at what, pi by 2. Then if you can draw a cosine wave, so all of this is to kind of show you how you can take the math and you can kind of improve on the math, and then we can put all of this into code very simply. So if I draw a cosine wave over here, I'll draw a bit of a bigger wave so I can use it for reference a bit better. So this is a 0, this is going to be a pi by 2. So that means this is going to be a pi. And if this is a pi, then this point is really just a pi plus pi by 2. So that just leaves you with 3 pi by 2. So really what you're getting is something like this. So you can do 1 pi by 2, 3 pi by 2, 5 pi by 2, right? So really it's just an odd number series times pi by 2. So that can just be replaced by the term 2k plus 1 pi by 2. So that just tells me that theta is equals to a 2k plus 1 pi by 2. And here theta is equals to a k pi. You can check out why that's the case. It's way too simple derivation, so I'm not really going to jump into that. You just need to know your trigonometry. Alright, so that leaves me with two solutions, actually n solutions, infinite solutions, but there are two distinct solutions. So over here I know that it can either be this or this, but there's still a tiny problem in this solution that we have gotten. Both of these aren't correct. Actually, they are technically correct. They are two stationary points on the graph, but one is a point of maxima and one is a point of minima. You need to figure out which one is a point of maximum. Now, there are two ways in which you can do this. The first way is to actually do it in the mathematically rigorous way, which is to use the second derivative test, and you can kind of figure out if the second derivative is positive or negative. If the second derivative is positive, then that pretty much means that it's a minima. Second derivative is negative, it's a maxima. So for one of these, the second derivative is positive, one of these, it's negative. But we'll use a little bit of common sense because I don't want to dive into that rigor. If we can just use a little bit of common sense and find the right answer, right? So over here, if I kind of expand it, if I kind of write out a few terms of this series for the cosine, I can get it that it's something like pi by 2, 3 pi by 2, but I want to restrict myself up to pi by 2, so I'll tell, okay, theta is pi by 2. Over here I can say that theta is 0 or theta is pi. What does it mean for theta to be 0 or pi, and what does it mean for theta to be pi by 2? Let's imagine, so if this is the projectile that we are drawing, so if it's something like this, if theta is pi by 2, it pretty much means that I'm throwing it straight up like this. While if I say that theta is 0 or pi, it pretty much means that I'm throwing the projectile straight like this or straight like this. In this case, the height should be 0. And in this case, Sy should be maximum. So this is our answer. Pretty simple, right? I know it kind of seems all complicated, I'm guessing, but it's pretty simple actually. So that leaves me with these answers. So in reality, we accept this one as our answer, and we can kind of limit theta from like 0 to pi by 2, but I'm not really going to write that, it's up to you. So now we can also optimize for Sx. It's a very simple optimization problem again, so we can just do a dsx by d theta. I would highly recommend that you work out the math yourself. One little thing that we can just do is I'm gonna split out like the constant terms. I'm gonna write them down a bit separately just because I can, and I just want to show that that the constants and the variables are kind of separate. So I can just find a simple dsx by d theta. The constant remains a constant, and I can pretty much put it in a bracket now. First, I can differentiate the cosine, that just leaves me with a negative sine square theta, and then I can differentiate the sine, which leaves me with a positive cos square theta. Now, for the people who I think are a bit paying attention and who are decent with the trigonometry, I think, well, I can kind of just rearrange this equation, right? Because I can just say that this is a cos square theta minus a sine square theta. For the people who really like trigonometry, are actually like even decent with trigonometry, well, they know that this is a simple formula for cos 2 theta. I'm guessing you know that. But yeah, this is what the equation for cos 2 theta is. So again, we can just do a simple optimization. We need to find the stationary point, so we still know that cos 2 theta should be equal to 0. We know that for theta, we know that for cos theta equal to 0, theta should follow 2k plus 1 pi by 2. So here we can just say that 2 theta is equals to 2k plus 1 pi by 2. So that means that theta is equals to 2k plus 1 pi by 4, and that gives you the answer for this. So we have optimized this and we have written out all of the mathematics. Wow, it just looks good. I really like the look of just having, just working out the math. It's just way too elegant. And, sometimes I really like to do this stuff even more than actually coding it out. It's just super fun. So I hope you kind of, you know, enjoy and share my love for math. So yeah. Alright, so we have all of this math up here, and we have our solutions. We have our Sx and Sy, and we also have equations for time, and we have everything. So okay, I'll just make a box out of it. Is we have total, actually I think I made a slight error in this, so I'll tell you what the error is. This is a subtle error. Alright, this is a, actually it's not so much of a subtle error, it's kind of a big error. And I figured that out when I was making the box around this time equation. I think a lot of people might have spotted this. So the time I measured was for the ball to reach the maximum height. It was not the total time for the projectile to actually reach the ground again. That's the big error, because in this case, since the projectile's motion will be symmetric, the total time is really just going to be 2 times this. So really there should be an extra coefficient of a 2 over here. So that's pretty much the error that I had. So we pretty much just added 2 everywhere over here. So we just say sx equals 2, and it doesn't really change the answer. The answer pretty much remains the same because all of this is just a coefficient which just goes into the LHS, which is the 0, but you need it for the actual SX equation. So yeah, that kind of matters a lot in that way. So you can make a box out of this. I'm gonna make it as, I'm gonna, whoops, uh, say t total and 2u sine theta by g. So we can put a box around that one as well. Okay, come on, bro. Alright, done. Cool. So we have all of these equations and all of this math, and you can finally put it into code. Wow, it just looks good. Alright, it just looks good. Believe me, you like math or not, when you see a page like this, it looks elegant. Alright, so we have the math. Now let's actually dive into the code. I'm gonna use that as a reference, obviously. If anyone has done it with me, and you can even you do that yourself. Alright, so it's been 21 minutes. I mean, that's decent. We got it done pretty quick, actually. Alright, so let's actually jump into the code now. I'll open up my terminal window and we can pretty much just get started. Alright, so I'll cd to my desktop and I'll just make a directory on my desktop. So make the projectile motion, and I'll cd to projectile motion. Alright, and oops, touch main.py, and I'm a bit in the mood for some Vim. I haven't used Vim in a while right now, so I'm in the mood for that. Alright, there we go. So we can just import pygame, import math. I think we'll need math. I'm not sure if we will actually. Actually, I don't think we will need math. What we are doing is like very, very simple operations, really. We are not actually doing, actually, but we might just need it, so I'll import it for now. I don't think we'll need anything other than this. So alright, so first I'll just set some of the variables. So I'll set screen width. Now all of this is going to be based on your display, so you guys are going to have to check it out. So my display dimensions are a lot different than your display dimensions. Even if you are using a Mac yourself, I work with I work with a non should I say, I don't know, I don't work with the default setting for display. I have modified my settings slightly, so my display kind of accommodates more pixels and makes everything smaller. So in that case, for me 800 by 600 will be pretty small, but for you guys it might just be very large. So try to kind of accommodate that correctly. So I'll just say pygame.display set underscore mode, and we pretty much just pass in a tuple of width and height. It's been a while since I've done any pygames. Seriously, I mean, it's just fun. So I can then just say pygame.display.set underscore caption projectile motion golf. Alright, and then we can just create the, actually no, I don't think we ever did. So while running pass, and we can then just set a running to true. So for event in pygame.event.get, if event.type equals pygame.quit, running equals false. Alright, done. That's all the code that we need to write for the game loop, I guess. I'm not actually sure. It's been like a year since I've done any pygame, so I have forgotten a lot. But seriously, it's good to do some of that stuff again. I've been doing a lot of like school assignments and stuff that I like doing, but still Alright, so we have this projectile motion called fender. It's hard to see how big it really is because my entire wallpaper is black, but still, if I just put it here, you can see it's actually a very small screen. For me, 800 by 600 is pretty tiny. So, alright. Okay. So, for now, what I also want to do is I want to change the color a bit. So, how do we do that? I actually don't remember. Uh, I know that there was a. I think there was a screen dot fill kind of a thing. I don't know. I'm gonna have to Google this. Okay, so we can search for it. So Pygame change background color. I think it was a screen dot fill. I'm like 99% sure. And I also had to do a Pygame display dot update. I forgot that. Bro, I've forgotten a lot of Pygame. Alright, so I'm gonna set a background color. I'm gonna set it to white for now. We might change it a bit later. So white. Actually, I'm just gonna call it BG color, and we're gonna set it to white. And I don't know, keep something that I like. Or whoops. All right. Okay. So screen dot fill. Okay, I don't really understand the entire pygame dot display dot flip thing that people do. I don't want that. All right. You know what? I don't think there's a better place to learn stuff that you have done a while ago than from your own previous code. So I'm gonna look at my own GitHub. This is another repository. I don't want to view this one. This is actually a private repository. I don't think. Yeah. All right. So. Okay. Yeah. Okay. So I know that for my agar.io project, I had used Pygame, so I can check that out. I don't want to download a zip file unless I absolutely have to. So, and I'm not gonna do that. I have a couple of repositories. I'm pretty sure. I mean, one of my things at least has. Okay, not smart scan, not this, not this, not this, not this, not this. Yeah, I think it's this one. So there was this Frogger game that I had built. This was actually done on a. This was like a YouTube tutorial series on Pygame. So I'd written some code. A lot of it was done using classes and objects. Back then, I really kind of cared about the code that I wrote. At this point, I just want to get stuff done. Oh, I forgot to initialize Pygame. Damn, I've forgotten a lot. So pygame.init. I really just been doing a lot more of neural networks and more of like serious stuff these days. Back then, I really just did not care about the stuff that I did. Alright, so see, I told you there was a screen dot fill. I was correct. Alright, so you do it at the start of the loop. That's another thing that I kind of call, I guess. So we pass in it as a tuple. So screen dot fill bg color. Alright, and I also need to update it. I'm pretty sure. There we go. I was correct. That's nice. Alright, so we just do a simple pygame dot display dot update. Done. And obviously let's run this. There we go. We have a white color display. I like this one a bit better because otherwise everything was kind of fusing in with my wallpaper, and it was kind of hard for you guys to see, so I'm gonna keep it white for now. You guys can obviously play around with any colors you want. It doesn't really matter a lot. Alright, so we have all of that in place. Now actually let's create the ball itself. So should I use a class or should I not? I'm a bit conflicted. Because the thing is, we are not really creating anything that's too complex. My goal is really just to create something that's basic. Like, should I create like an entity class and stuff? Because the one problem that I'll get if I use classes and objects is that my collision system will kind of go a bit haywire. But that's also not too big of a deal because I mean, I'm kind of debating should I use a class or not, because the project isn't like 5-10,000 line project that I need to be a bit clean with my code. This is like 100 line project at max, so it's not like I need to be clean with what I write. I can do it however I want. Because these days, I've been a bit like, I initially I used to care a lot about code completion even when I wasn't dealing with a big project. These days I've been dealing with big projects and I do care about code quality a lot, but sometimes I just like to write and get stuff done. Because these days some of the projects that I have been working on, they are like, for me they are decently sized projects, like they are like a couple of thousand lines of code that I have single-handedly written. I wish I could show you some of them, but I think I might. But don't count on it because it's gonna take a while before I can actually showcase that. Maybe I think it's gonna take me like a year to finish it. So maybe next year. All right. So we have a, what, for now I'm gonna not use a class. We might maybe then pivot and shift and use a class, but for now I'm not gonna use it. All right. So should I do the drawing and stuff after I've done this, or should I do it before? I'm actually not sure. I think it shouldn't really matter. I'm gonna do it. Okay, I actually. Whoa, what just happened? I think I quit by mistake. Yeah. Alright. So I think I'm gonna do it after, because as far as I can remember, that's how I always do it. So draw the stuff. Alright, I don't think I need the comment. Yeah. So ball is equals to, how did we do the drawing? So ball equals pygame dot draw dot circle, and we want to draw it on the screen. I'm gonna Google draw, not break, draw a circle in pygame. Alright, I do not want to watch a YouTube video for this. Just give me some kind of an AI suggestion, or I don't care. Alright. Okay. Alright, so it's the surface that you draw it on. Then it's the color, and then it's the x and y coordinates, and the radius of the circle. I'm not sure if it's radius or diameter. I guess it's just radius. So that color, we'll just pass in as black. I'll define black. We might use it somewhere else. I'm gonna put it in a variable itself, 000, and we can just pass that in. Okay, so x and y are a list. So for now, let's just do 10 10. For now, I'm just kind of doing a proof of concept kind of a thing, and then we have to do, I guess that's correct. I guess that's enough. Let's just hope it's correct. Yeah, it is. Wow, I get a ball. That's cool. Now we obviously need to position the ball correctly, but that's, my first order of business was to actually get the ball showing, and now we can get the ball rolling. So okay, we now need to position the ball correctly. I'm gonna do a kind of a dynamic position, so I think it's x and y. So I'm just gonna do width over 2, and I'm just gonna do a height minus radius radius. Oops. Whoa, what just happened? Come on, man. This problem with this stuff. Alright, so height minus radius times 2. And here we can just set the radius. And we can put this line and define radius as 10. And I guess that's correct. Not sure. Yeah, that positions the ball exactly where I want it to be. If I want it to be grounded, I could kind of do that. So now the next order of business is to actually add gravity. How do we add gravity? Well, what is gravity? Gravity is the change in the y coordinate of the thing because there's a downwards force acting on the ball. That's kind of like a decent definition of gravity. You need to add that now. So I can set a variable gravity. Set it to 10 for now. Let's use like a actually, you know what, let's just set it to 1 for now. You can't really use 9.81 when we are dealing with code because well, code life is not the same as real life. Code life depends on your computer being able to process stuff. Real life depends on, well, the earth for gravity. So for now we'll just set it to 1. Keep in mind you're gonna have to scale everything down to fit this. So gravity is 1. Really what I need to do is change the ball's x coordinates according to the gravity. So for that I need to set the ball x coordinates. So ball x should just be equals to the width divided by 2. So now here, instead of having some kind of a constant, we just set it as ball x. And obviously not ball x, I really need to change the ball y through gravity. So I obviously need to define ball y. So I'm going to do ball y. Ball y. So that's going to be equal to just the equation that we wrote, which is height minus radius times 2. I would highly recommend you to use stuff like this, like, you know, using maths even in your variables. It's always a good practice to be a bit more mathematical because mathematics is rigorous. All right, it's rigorous. When you write something down in a mathematical statement, there is no ifs and buts and edge cases to it. It will always be this, and that's a good thing because, you know, it is dynamic, and there, if there's one change, it kind of, there's a repercussion on every other variable, and there aren't any magic numbers or loose ends. It's all tight. So, you know, that's just a little trick that I never did that when I was like new to programming, and, you know, I always regret that. And, you know, if there's anyone that's new, please do something like this. It's a game changer. So if I just do a simple ball x minus equals gravity, actually I think I should do a plus equals gravity. I'm not sure. I think it's I've forgotten how the coordinate system works in Pygame. As far as I know, it is I need to do a plus for it to fall down, but again I'm not sure. We will see. Okay, that is technically correct, but one tiny error. It's not ball x, it's ball y. So we can just do a ball y. Now there's also another physics error in this, and I'll show you what that is. It's a cool physics error because, you know, it's the ball falls down. I know a lot of people will say, well, that's victory for me, bro. The ball is falling, nice. There's a tiny error. What we are doing here, it's not gravity, it's just a constant velocity. We need to scale the constant velocity. So we need to actually use through that, and we need to add gravity to some kind of a current velocity. So for that, we set a ball y change. So and paste. All right. So ball y change is pretty much just going to be equal to 1 for starters, but we need to add the gravity to it. Now for this we need to set a frame rate. I'm going to set a frame rate because if I set a frame rate, it allows me to add gravity by a certain amount to my current ball y change. So you need a frame rate for something like this. So I'll set clock is equals to pygame dot time dot clock, and I'm gonna set an FPS over here. So FPS, what I'm gonna do really is I'm gonna set some of these variables apart from each other. So FPS equals 60. So we're gonna play this at 60 FPS, no more, no less. It can fluctuate a bit, but initially what was gonna happen is it would fluctuate a lot, and I had no control over what the FPS was. But in this case, I know that the game should be playing at 60 FPS, and so any calculations that I do inside the game loop, I know that they're going to be updated 60 times every second, and so I can scale my calculations according to that fact. So that gives me a bit more control over my game, which is very important in a physics simulation like this, which is to actually maintain some kind of a constant FPS. So I just need to know, okay, so I know for a fact that, okay, so clock.tick should be at the very end. Alright, so it should be somewhere over here. So it should be clock.tick FPS. So it should be something like this. What this should allow me to do is get a constant FPS, which is awesome. And now I know what I'll do is I'll make another small amendment, which is that I'll just make this ball y change. But now we have to change the ball y change by gravity. Another thing that I should do is I don't want to set gravity to 1, because in that case my ball y change will change a lot. So I'll make gravity 0.2. Actually, yeah, I think 0.2 is good enough for now. And I'll also just make this radius times 10 for now. Okay. Alright, so we have gravity and we have ball y change. I wanna now, how exactly does acceleration work? Recall SWAT equation v equals u plus at. We have a v, we want to find a v, we have a u and we have a at. T can be anything that we want. So in reality, it's just that we are constantly shall I say, adding that quantity to u. Okay, I'll actually have to share my screen for this, because I think, because I mean I get the intuition, but I think I remember when I was like, if someone's not that experienced and watching this, and they might have a bit of a trouble grasping this. So if I say that, okay, if I say that vy equals uy plus gt, well, in this case I really don't care about t for now, at least. I don't really care what t is. So, but still, I mean, g is multiplied by t, right? So let's say I don't really care about t, or let's say that t is 1 second. In that case, well, vy is really just uy plus g. I know what uy is, I know what g is, and therefore I can figure out what v is. Now imagine if I'm doing it for t equals 2 seconds, right? So reality, what this is that I'm just saying that vy equals ui plus 2g. Very simple. So that just means that vy equals ui plus g. Simply writing it, that's just vy equals ui plus I equals 1 and g, and you kind of keep on adding those many g's. That's kind of what you're doing, right? And this is effectively what we are coding, because we are going to be in a while loop, and so we're going to keep on adding g. Very simple, right? Pretty effective. Works nicely, and that's exactly what we're going to do. So alright, we know that. Now for this, I'm going to make a function, because I think we're going to be a bit more effective if I use a function for this, and I think you shall see why. So add gravity, and effectively I'm going to take in two parameters. So I'm going to take ball y change, that's effectively velocity in the y direction, and then I'm going to take the gravity. And really I'm just going to do ball y change plus equals gravity. Should I use mean, it can't exactly return that, right? I don't think I need to do this. I don't think I need a function. I think I can just do it directly. And here, I'll also do one last thing. So ball y change plus equals gravity. If my physics and math is correct, this should work. I'm guessing this is a very crude way of doing it, but well, oh, you gotta be kidding me. How do we do that stuff? Ah, okay, so it's a capital C for clock. Again, I haven't used Pygame for a while now, so I don't know how this stuff works. That's awesome. It worked. Alright. I don't think a lot of you guys could exactly see what was happening, so I'm gonna make this a bit bigger. So we have a bit of a larger amount of time to actually see what was happening, and that it's actually a cool thing. So you can see the ball gets faster, and it gets faster by a constant amount, which is awesome. Nice. So it worked exactly as we wanted it to work. Now we'll just do a bit of a basic boundary check. So the ball doesn't actually fall down. I don't really want that stuff to happen. So we'll do a quick boundary checking thing. So we can do a quick boundary check. So if ball y is okay, so 0 0 is at the top left corner of the screen. So bottom is height. So ball y is greater than equal to height minus radius. Then I'm gonna set ball y to height minus radius. It's as simple as that, really. Oops. Okay, that should be good enough for now. Okay, why is the ball able to travel down? Okay. What is happening is there's still a ball y change, I'm guessing, so I need to set ball y change equals 0 and gravity equals 0 for that time being. There we go, it's working now. Alright, that's good and all. Alright, I am not sure if I handled this the best, but for now we can just work with it. Alright, so we have a basic y acceleration in place, and you can see that it works like a charm. It works pretty well, actually. So now we need to actually take into account a shooting of a ball. So first, let's just take into account a ball being kind of thrown upwards. Because of that, I'll first want to position the ball exactly on the ground, so I know for a fact that the ball is going to travel upwards. So I'm going to set gravity to 0 for now, obviously. Alright, so now we're going to set some kind of a ball y change. In this case, the ball y change has to be negative, so I'm going to set that negative. And in this case, gravity is also going to be negative. Actually, is it going to be negative? No, it's going to be positive, right? Because velocity. Okay, so you can do it in two ways. Since Pygame works kind of in an opposite way, we're going to set gravity as positive and y change as negative. In a real life calculation, you would set y change as positive and gravity as negative, since a Cartesian system kind of works like that. You can you can check all that out. So we can set gravity as positive and y change as negative, and we are constantly going to add gravity to y change. So reality, it should work. Also, I think I don't need to add that equals to it. Let's do that. Boom. Alright, now there's a tiny problem with this. It is that alright, so I'll tell you what the problem is. The problem is that the ball is there, so I'm gonna set it to 2. Okay, why is the ball still falling down? That doesn't make any sense. Ball y change is negative. We are adding 0.2 to the negative, so it slightly becomes less negative. I mean, everything is correct. Why is the ball still... Okay, for now, we can just kind of get rid of this stuff. I don't want the boundary checking to hinder my other stuff. It's not as important as the actual physics for now, so we're gonna leave that. I'm just gonna see just raw physics. What does it look like? Okay, so the ball falls down still. So that's the issue that we need to sort. What I wanted is the ball to go up. For some reason, the ball is going down. So what I'm doing is ball y plus equals ball y change. Ball y change is still is -1. Why is the ball then going down? Okay, let's just set it to +1. The ball is still going down. Alright, another thing that I'm gonna do is just make this 20 again. I wanna get some room and actually understand what's going on. Alright, I mean I get that, but why is it still falling down? It shouldn't. So ball y plus equals ball y change, and I'm doing this too. So ball y is, let's say, so the screen is 400, no, it's 600. So ball y, let's say ball y starting at 300. All right, I want it to go towards 0, so I want it to change by -1 every second. So in reality, this should technically just be negative. All right, that's good and all. What just happened? Alright, so that should be -1, and if I just get rid of gravity for now, then technically the ball should go up. Technically the ball should be going up. Nice. Okay, we at least have that sorted. So the ball is going up. Gravity works in the opposite direction of the velocity. So gravity is going to be 0.2, and we constantly add gravity to y change. I'm guessing that the gravity is very large. Maybe that's why we are facing that issue. So if I set a much smaller gravity, then maybe I should actually see something cool happen. Alright, so I think I set the gravity something to too small. I think I should have set it a bit larger. I'm gonna increase it by 10 times. I'm gonna make it that much. Nice. You can see that we can actually see a bouncing ball. Actually, not a bouncing ball really, but I think you can kind of see what's happening over here. So that's awesome. Wow, I really like it. So okay, we're gonna change the gravity up a bit. It's a bit messed up right now, but you can see what's happening here. It's really cool stuff. I like it. It's awesome. Nice, look at that, it's just so beautiful. So you can see we just simulated a projectile being fired at pi/2 or 90 degrees. That's awesome, that's awesome. Okay, how long is the stream getting? Because I mean it's 12:30 and I'm a bit sleepy and stuff, so yeah. Okay, it's been on for 54 minutes, and we did get a decent amount of work done. I mean, we didn't really write a lot of code, but we did a lot of math, and we kind of brushed up on my Pi game skills and stuff. So that's definitely decent stuff that we did. For now, let's just stop the stream, because I know the bulk of the work is to actually get the projectile working. Because we also now need to set a ball exchange. Because really for ball exchange, really all you need is to set a ball exchange, and we can just set it to some kind of a constant value, which is just going to be 1, and then I can simply just go down over here and set this is all I really need to do for the ball to move ahead. Now the core part of the thing is to just to get the projectile to work in that kind of a parabolic thing, which can be done by using these equations that we had set. I think that should be good enough. So basically what I can do is I can use the equations. So I don't know how that's kind of gonna work, because I can get the two systems to be working kind of simultaneously, but working in tandem with each other is something else entirely, something that I'm not exactly sure how to do, because I have the equations. Technically I have an equation that models the motion for the thing. It's just 2u squared cos theta sine theta over g. If I use that equation, it should technically model the sx, or the maximum, or the distance given an angle theta that the particle should travel at. And since I but I'm not sure, so we'll look into all of that in the next stream, which will probably happen sometime in the future. Don't really depend a lot. I might just make a video out of it, I'm not sure. But for now, this is what we have, and I hope you had some fun. I mean, I wrote a little bit of code, and I definitely had a lot of fun. So I hope you enjoyed the stream, and if you did, definitely like and subscribe to the channel. And I'm sorry for not uploading for a while. I really just been very very busy with a lot of stuff right now, and I think now I mean I have finished up pretty much a lot of it, and so I technically do have a lot of time, but still a lot of commitments to meet. And I'll try to shoot more, I'll try to record more videos, and I just hope that I can actually fulfill that promise. That's why I know it's not really a promise. I just hope that I can actually do that, because I don't want to make any kind of false promise to you guys. I really do like making videos. It's just that as a student, that kind of takes priority one for now. So all right, so that's it for this stream, and it was really fun to stream again, and I hope I can do that in the future. Until the next time, stay tuned for more streams. Like and subscribe to the channel, and I'll see you soon.